Making Decisions, Part 2. Note, this presentation doesn't replace your book. You're still going to have to use your book. You're going to have to look at the details in there, and we're going to ask you to do that a little bit later. But the idea is that there's more detail in your book than we could ever include in this little video. Now, last time we were together, we actually looked at these different objectives, and now we're going to introduce you to these objectives. Here we go. We wanted to review a little bit before we started, so see if you can trace the if, then, statement, end if. This is a dual alternative structure. We've got the same kind of thing, if, then, else, end if. So trace the if, then, statement, end if. Trace the if, else, statement, end if. And don't forget we write it if, then, else, end if. Oftentimes you need to make more than one decision. So let's kind of take a look at this. First of all, you'll notice that these decisions are nested. Notice the diamonds are nested. One follows the other. So let's just kind of trace this through. We reach our first condition. It says if the salary is greater than or equal to $30,000, and if that's true, let's say we earn $31,000, then we're going to go down here and say years on the job greater than or equal to 2. So if you've been on the job for 3 years and you earn more than $30,000, let's see what you get. You qualify for the loan. Ah, very nice. But you have to meet both conditions. Let's find out if you don't. So we say if your salary is greater than $30,000, and let's say that it's 25. Then we're going to go to the left, or the false, and our statements would read, you must earn at least $30,000, display per year to qualify, and then we go down to our end if. Let's say that we earn $35,000, but we've only been on the job for 18 months. If salary greater than or equal to $30,000, that's true. Then we go over here and we say years on the job greater than or equal to 2. That's false. So we didn't meet that condition. So we go to the left, or the else side, and we say display you must have been on your current display job for at least 2 years to qualify. End if, end if. So we've got 2 if statements and 2 then statements, 2 else statements, and 2 end ifs in this whole thing. That's called a nested if. So if we look at the nested if, it's if, then, else, end if. And we can nest them to make them simpler to write. So here's a real complicated one to figure out grades. So we say if the score is less than 60, then what? Well, if it's less than 60, display grade is F. So we've written a program to grade papers here. We're entering scores and letting it assign grades. If the score is less than 60, so anything less than 60, let's say a 55, would then get the grade is F, and at that point, the structure would be over and we'd drop to the end if because one if statement executed. Let's say that you got a 65. You say, if the score is less than 60, well, that's not true. So we go to the first else statement and it says, if score less than 70. Well, it is less than 70, it's 65. It wasn't less than 60, but it's less than 70. Then we display your grade as D. Cool, huh? And then we would drop through to the end if because it's already run one. Let's say that your score is 75. So we say, if the score is less than 60, nope, it's not that, so let's go to the else. If the score is less than 70, nope, it's not that, so we go to the next else. If the score is less than 80, yeah, that's it. Then we display your grade as C. Cool. Let's say you got an 82. So it's not less than 60, it's not less than 70, it's not less than 80. Is it less than 90? Yup, it's less than 90, so we display, congratulations, your grade is B. What if you got a 96? Whoa! So it's not less than 60, not less than 70, not less than 80, not less than 90. There's only one thing left. So we say, if it's not less than 90, congratulations, we don't have to test it anymore. You display your grade as an A, because that's the only thing left. And then we would end it all with an end if. This is a case structure, and this is where you have many, not just true or false kind of choices. So we could say, if the month that we've entered is January, then it's going to bop over and test January, or test the month variable, and it's going to put it in the January slot. If we typed in February, it's going to test February. If it's true, it's going to put it in the February spot. See how that works? If we put in June, it's not going to match January, February, or March, and as a consequence, it's going to put in an error. Now, in effect, what we really do is we don't put in the name of the month, we put in the number of the month. So we'd say if month equals 1, it would actually display January. If month equals 3, it would display March. If month equals 5, then it doesn't match 1, 2, or 3, and it would go into the default. Now, oftentimes, instead of doing nested ifs, we can actually do logical operators. And they're basically Boolean expressions. They're either true or false. So here we go. You can use and include both conditions. So let's say that you had two conditions that had to be met, this one and that one. Or means either meet this one or this one. Now, the way I remember that is or gives you more, and is always much more restrictive. So if you are male and have a green shirt on, then you get certain things. If you are a male or you have a green shirt on, see how that includes more people? The other one is not, which reverses the truth of the expression, and we really don't want to use not very often. So turn to page 158 and read the table 4 and the note after that table. Let's go back to talking about logical operators. Here's an and example. If the temperature is less than 20 and, there's that big and, minutes is greater than 12, then display the temperature is in the danger zone and in the if. So it's got to meet two conditions. Got to be less than 20 with more than 12 minutes exposure. Here's an or. If the temperature is less than 20 or the temperature is greater than 100. So what are we really looking for? We're looking for a range from 20 to 100. Then you display the temperatures in the danger zone, and we'll end the if. Okay, what about the not? The not is really hard to understand, so this is why I don't use it very often. If the temperature is not greater than 100, that's the way I read it, and now I've got to figure out what am I really saying here? Then display the temperature is below the maximum temperature. It's much easier to say if the temperature is below 100 than the temperature is below the maximum temperature, because I can deal with the positive, I can't deal with the negatives, especially when you get into real complex expressions. More on logical operators. As I said earlier, we're checking a range. We're actually going to do it by saying and. So we're going to use that thing inside the range. So here we go. If x is greater than or equal to 20 and x is less than or equal to 40, then display the values in the acceptable range and end the if. Now figure out what numbers fit in that range. Everything from 20, including 20, to 40. Here's an or. If x is less than 20 or x is greater than 40, then display the values outside the acceptable range. So what numbers are we including there? It's less than 20. So we're actually looking for 20, less than 20, or, so 19 and less, or greater than 40, so 41 and greater. Okay, let's talk a little bit about Boolean values. And you'll notice that they can only hold one kind of data, true or false. So it's going to be a 1 or a 0. That's it. It only holds one thing. And we often use them as what is called flags. So in our program, we've declared the Boolean value of the variable is lunch. So we've declared that a Boolean variable. So we say, if time is greater than 12, then set the is lunchtime variable to true. So we put true in the is lunchtime variable. Else, set the is lunch or is lunchtime variable equal to false. So if the time is greater than or equal to 12, is lunchtime is true. If it's not, it's false. And then we end the if.